I am Dan Gaude, Assistant Professor in Mathematics, Center for Distance Education, Shivaji University, Kolhapur. Today I will discuss the examples on Euler's Lagrange's equations, differential equations. Now see your example. Show that the shortest distance between two polar points in a plane is a straight line. In last lecture, we have studied the shortest distance between two Cartesian coordinate is a straight line. In similarly way, I will show that we have to show that the shortest distance between two polar coordinate is a straight line. Define a curve in plane a of xy and b of x plus delta dx y plus dy. Therefore, by distance formula ds square is equal to dx square plus dy square. Now let theta is equal to theta of r be the polar equation of the curve. Therefore, p of r1 theta 1 and q of r2 theta 2 be two polar point on it. Therefore, x is equal to r cos theta and y is equal to r sin theta. Differentiate by the equation distance between p and q is given by ds square is equal to square root of dr square plus r square theta d theta square. The total distance between the points p and q becomes I is equal to integral from x1 to x2 1 plus r square theta dot square raised to half dr, here theta dot theta dash is equal to d theta by dr, differentiating with theta with respect to r. Therefore, we have to functional I is equal to square root of 1 plus r square theta dash square, and the functional I is shortest if the integrand of satisfy Euler's Lagrange differential equations, that is d by f by d by theta minus d by dr of d by f by d by theta dash is equal to 0. Here d by f by d by theta is equal to 0. Therefore, and d by f by d by theta dash is equal to r square theta dash divided by square root of 1 plus r square theta dash square. Therefore, replace in Euler's Lagrange differential equations. Therefore, d by dr of r square theta dash divided by square root of 1 plus r square theta dash square is equal to 0. Here, differentiate and we get r square theta dash divided by square root of 1 plus r square theta dash is equal to constant ch. Therefore, rearrange this r square theta dash is equal to h into square root of 1 plus r square theta dash square, and squaring and solve for theta dash, and we get theta dash is equal to plus minus h divided by r into r square minus h square raised to half. Integrating, we get theta dash is equal to plus minus cos inverse of h divided by r plus theta naught. Theta naught is nothing but constant of integration. Therefore, Here replace theta minus theta naught is equal to, and plus minus cos, replace cos is even function, therefore plus minus is replaced by plus, therefore h by r is equal to cos of theta minus theta naught, therefore h is equal to r cos of theta minus theta naught. This is the polar form of the equation of straight line. Hence, the shortest distance between two polar points is a straight line. If r is equal to r of theta is the polar equation of the curve, then equation or length of the curve is given by I is equal to integral from theta naught to theta 1 square root of integral from theta naught to theta 1 square root of r square plus dr by d theta square d theta. Since the integrand f does not contain theta, we have solving this equation, we have f is equal to r dash by f by r dash is equal to h. Solving this equation, and we readily obtained the same polar equation of straight line as the geodesic. Now next example show that geodesic means shortest distance between 2 points. Phi is equal to phi of theta on the surface of a sphere is an arc of the great circle. Arc. Consider a sphere of radius r described by the equation x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, z is equal to r cos theta. If a, b, that is b two neighboring point a of x y z, b of x plus dx, b of y plus dy, z plus dz, be two neighboring points on the curve joining the points P and Q. Then the infinite small distance between A and B is given by ds square by distance formula is equal to dx square plus dy square plus dz square. Now r is equal to x is equal to r cos theta cos phi, r sin theta cos phi, y is equal to r sin theta sin phi, z is equal to r cos theta. Differentiate, therefore dx is equal to r cos theta cos phi d theta minus r sin theta sin pi d phi, dy is equal to, and adding, squaring and adding, therefore r square d theta square plus r square sin square theta d phi square. Hence the total distance between the 2 points P and Q along the curve pi is equal to pi of theta is given by I is equal to integral from theta 1 theta 2 r 1 plus sin square theta pi dash square raised to half d theta, where pi dash is equal to d pi by d theta, where f is equal to r 1 plus sin square theta pi dash square raised to half. Then it must satisfy Lagrange's differential equation di by f by di by theta minus d by d theta of di by f by di by theta phi dash is equal to 0. Here theta is not dependent, therefore phi is not, therefore di by f by di by phi is equal to 0, and di by f by di by phi dash is equal to pi dash divided by square root of 1 plus sin square theta pi dash, sin square theta pi dash, right? And we get d by d theta of r sin square theta pi dash divided by square root of 1 plus sin square theta pi dash is equal to 0. Integrating sine square theta pi dash square divided by 1 plus sine square theta pi dash square is equal to 0. Squaring and solving for pi dash is equal to c cosec square theta divided by 1 minus c square cosec square theta raised to half, and simplifying d pi by d theta is equal to cosec square divided by 1 minus k square cot square theta raised to half, where k cot theta is equal to t putting, and therefore minus cosec square theta d theta is equal to dt. Therefore d phi is equal to minus dt divided by square root of 1 minus t square. Integrating we get, therefore phi is equal to minus sine inverse of t and plus alpha, and phi is equal to alpha minus sine inverse of k cot theta, and here replace this sine inverse alpha phi minus alpha or alpha minus phi, and sine is the odd function, therefore sine of alpha minus phi is equal to k cot phi theta, and k cos theta is equal to sine alpha sine theta cos pi minus cos alpha cos theta, sorry, sine theta sine alpha pi. Therefore kz is equal to x tan alpha minus y cot x tan alpha x sin alpha minus y cos alpha. This is an grade of arc of great circle. This is the first degree equation in xyz, and which represents in a plane. This plane passes through the origin, and hence cutting the sphere in a great circle. Hence the geodesic on the surface of a sphere is an arc of a great circle. Arc of a great circle. This is our today task.